Hello again, students. I want to continue our discussion about production and look at break-even points. So this is where we transition from kind of using the theoretical graph and getting an idea of where the profit maximizing quantity is to look more generally. Not every organization has the goal, and not every business for that matter has the goal of producing right at that quantity all the time. Instead, there's a range of quantities that give us different goals. Some quantities, are for gaining market share. We want to sell as much as we can, even if it may reduce our profits. We may want to we want to have an idea of across different prices and different quantities what's going on with our profit. So one thing here, so we have, let's say that this is our price line, P star. We want to keep in mind that our profit equation, Q star times P star minus ATC, like we covered, this gives us a lot of information, and we really want to focus on it. So if this is P star, look at what happens as we're scaling up. So we're getting a marginal revenue here, or that's the price that's coming in. But this average total cost is quite high. So anytime where average total cost is greater than price, we're losing money. That makes this a negative term. So we're losing money. So all along here, profit is negative all along until this point. At this point, profits start getting positive, okay? Beyond this pot, the profit I attain at this point starts being positive, okay? So that's related to going from negative profits to positive profits. Again, here's another point. If our goal is to be at the most efficient cost, maybe many organizations want to be there. That's where you would be. You'd be having a solid, solid marginal profit. But over here again, this is the max profit point. This is where you've attained all of these positive profits. So that being said, I want to talk about two examples. As you're reading, you'll see that the break-even analysis article that I asked you to look at, it comes up with this nice equation here. FC, fixed cost divided by the difference between price and variable costs. This gives you your break-even point. I made a little spreadsheet that makes this a little bit easier to understand. You can fiddle around with it, but here's a price I put in. Let's say our fixed cost, you can type in, if let's say you have a list of fixed costs, that'll add it up there. And let's say you have several variable costs for something that you make, okay? So this is all very simplistic. Really one fixed cost, and the variable cost it's not going to rise over time, so it's going to be more simplistic than what we're looking at. Usually these variable costs would start to rise. So this is a simple example, but I just wanted to show you that this will be what the graph looks like on it. I put this together. Again, you see price is consistent, so this is indicative of us being able to see the market price. I put in a range of units, so that can show as we increase scale what's happening. Total sales revenues. Well, total revenues is quite easy to find. You just however many units you have and how much you sell them for, the combination of that is total revenue. Total revenue is equal to price times quantity, okay? And so you can take that and you can scale up all the way up to here, okay? Total fixed costs, again, this takes it from the previous table. You input this. These are unchanging over time. Total variable costs are simply whatever the variable cost amount is that you input, 7 times the quantity. So those go up 7 times the quantity, 7,000 here. Total costs is just your fixed costs plus your variable costs, so that's added up. And your profit is your revenues, total revenues, minus total costs. So you start off not making a very good profit, right? And then marginal revenue, you can, marginal revenue is the price here. So it's 15. Average fixed cost is this fixed cost divided by the quantity. Average variable cost is the same, the total variable cost divided by the quantity, and average total cost, variable cost is all the same. These are all calculated. So what does this show us? Well, it shows us this, okay? Here's our average total cost line. It goes down much like what I mentioned before. Average fixed cost is going down. Your average variable cost is a straight line, so this again is a bit more simplistic. And we have our marginal revenue line, which is $15. So what do we expect from this? What is the break even? Well, the break even is where you go from negative profits to positive profits. So it's around here. It's between 12,000 and 13,000 units. So if we go over here, we can look at what's going on here. It's approximately this point. Well, it's where marginal revenue crosses the average total cost curve for the first time. Everything before, again, costs are higher than price, we have negative. It crosses that line, that's when profits become positive. That's exactly what's going on here. But that doesn't mean that we want to sell at, or we want to produce at 12,500. Because as you see, profits start going up. And in this simple example, profits go on up into infinity because we have no increasing costs, which is not realistic. But it's a good model for for a small business that's getting started. So our break even here is between these 2 points, about 12,500. Okay, I wanted to add a more complex example here. So this example you can see is more complex. Here our averaged variable cost is going up, more like the theoretical graph. So as we are getting more of these supplies, it's putting price pressure, cost pressure up. So those costs are going up. That's leading to a increasing marginal cost curve. But again, we have a marginal revenue curve, that's our price. So this looks more like the total per unit cost graph. So again, we can look at the numbers here and see what's going on. We see we start off with negative profit because we have very large total fixed costs. But at some point, those go from negative to 0. Okay? So again, that's about between 4,000 and 5,000. What's going on between 4,000 and 5,000? Well, same thing as before. Before this time, marginal revenue is underneath total costs. So average total cost is greater, so that's negative profit. Once it crosses, we cross into the positive profit. Okay, so break-even point is right here at 5,000 units. That's our break-even point. We see that profits continue to increase to a point. They start to increase up until about right here. We don't get a good, I think it's, let's call it 9,400. You can input that. I think that's precisely the, or approximately the profit max. And how do we know that? Well, that's where marginal revenue is almost equal to marginal cost. Remember, this is our first decision. When marginal revenue equals marginal cost, we're getting our profit max. So that's at 9,400 units. All right, 9,400 units is right here. Well, it must be right here, right? Because that's where our marginal cost curve equals our marginal revenue curve. So that's our profit max amount. Okay, Now, final amount, so that's our profit max amount. Where is our efficiency? Where are we most efficient at? Well, we see that average total costs fall, which we see with the yellow line. They're falling here, and then at some point they start rising again. So our efficiency scale is around 8,000 units. Okay, so it's just a bit below where we are profit maximizing out, but that would be our efficiency scale. So 3 points again: break even, efficiency scale, and then our profit max piece. One more idea I want to show you is you may be getting, you'll be getting some different information that you still want to be able to manipulate and come up with, okay, what's going with, where would profit max be? Where would break even be? So you may be in a different situation where your costs are not that complex. And maybe you have some ideas about demand, and that's what I wanted to show here. You have a nature of your, let's say, I like this example because we've gone to a local tree seller, and they, if there's only one tree seller, that tree seller may have to decide, we have all these trees, what should be the right price, okay? So let's say that this tree seller has a cost of about $20 per tree that they plant. And they have an idea of what their demand curve is, 100,000 minus 2,500 P, okay? From this information, this can take us a long ways, okay? We can use this information to determine, hey, what should we price our trees at? There's going to be a range, of course, but we want to know what's the right price to maximize our profit. So what I want to do here is I want to show you how to set this up. All right. So I am starting to set this up with price. Okay, what I'm going to do is we're going to try a range of prices here, 1, 2, etc. Our quantity is just a function of the price. Remember, our quantity is this demand regression, this demand equation. So when we change the price, the quantity demanded goes down. So I'm going to put that into Excel, 100,000 minus 2,500 times P, right? So that's that right there. My total revenue is P times Q. That's total revenue. Total costs are however many trees I plant times that $20. So I put that in there. Since I have total revenue and total cost, I can calculate profit. I start off, at a very low price. I'm making a terrible loss. I put this in here, price elasticity of demand. So how do we calculate price elasticity of demand? Well, what do we need to know? We need to know the results from our regression equation, our demand equation, which is right here, minus 2,500, times a point on the demand curve, price divided by Q, and that's what I do right here. So minus 2,500 times price divided by quantity. Now, I do a little trick here that I'll put on the web, but there's a little bit of a fancy equation here. Elasticity is related to marginal revenue. So I can from elasticity, I can calculate marginal revenue for a given price. And then my marginal cost is equal to my average total cost here, because average total, since I only have one variable cost, that rises per tree. So marginal cost and average total cost are the same here. So that's always going to be 20. All right, what I'm going to do is scale this up. Okay, so I'm going to go from 1 to 2. That's going to change my quantities, revenues, costs, profit, elasticities. The only thing I want to keep constant here is 20 here, because 20 is not changing. 20 is the cost per tree. So I'm going to scale this up and populate this thing and see what's going on. Well, you start seeing that I put this graph together. we started moving up the demand curve from $1 to $2 to $3. It's calculating the quantity demanded, it's putting in the marginal cost, and it's putting in this marginal revenue. Now what's this mess up here? Well, I've gotten to the top of the demand curve, so I don't want all that. You see, that was the top of the demand curve at $40, and things start messing up there. So what's going on here? Well, we can look at, here's my marginal revenues, here's my marginal costs. Where those two cross is actually going to be where I'm maximizing profit. Okay, so that's at 20 and 20. So when price is $20 and marginal cost is $20, that's where I am. Where marginal revenue and marginal cost is $20, that is right here. This is my profit max, and you can tell that profit is negative, and then it breaks even, then it maximizes and goes down. So at this point, $30 and quantity of 25,000 is right here. So just as theory would predict, marginal revenue equal marginal cost here, that's the maximum profit. Break-even point is where profit is zero, and it goes from negative to positive. That's at price at $20, selling 50,000 units. So $20, 50,000 units. So that happens to be where the demand curve crosses the marginal cost curve. So I have I have this kind of lined up. These low prices, at these low price points, I'm making a negative profit. I want to stay away from there. So everywhere up to $20 is the profit's the price is too low. I'm making a negative profit. My costs are too high at this point, right? So everything below the cost curve is negative, and then we break even at 20, and profits start rising really nicely until they maximize at $30, which is right here, right here. So $30 is where I've maximized my profit, and that's sums up how you can approach, use Excel to calculate these things, giving different points of data. Depending on what your data is, you can try to flesh out what's going on here. All right, good luck.